the goal of this evening series is to introduce our friends to the excitement of brain research at Columbia, soon to be housed at the Jerome L. Greene Sciences Center at the new Manhattanville campus in Columbia. Now, if some of you have joined us before for some of these events, we are delighted to have you here again. And if this is your first time, we hope that in a small way we can help you capture some of the magic of Columbia. Now, understanding the human brain is the greatest scientific challenge of this century. How is it that this organ that weighs less than 2% of your body weight, yet consumes 30% of all energy and oxygen, transforms the human condition and turns sadness into happiness, fear into courage, conformity into creativity, and of course, despair into hope. Our goal at the Mortimer Zuckerman Mind, Brain, and Behavior Institute is to transform these abstract concepts into the language of biology. What's the plan? To bring together and to recruit the brightest, wildest, craziest, most ingenious minds, and to let them loose in this new environment to help transform our understanding of the human brain. Now, tonight is a very special event, in particular because we will have two very special guests. These are the philanthropic visionaries that help transform an idea, an initiative, into a reality. And first, I'd like to thank Chris McInerney with us of the Jerome L. Greene Foundation for giving us such a wonderful home, the Jerome L. Greene Sciences Center. I will later, when Mort shows up, acknowledge Mort's terrific contribution to this venture. Now, what about tonight? So, Aristotle claimed in the 4th century that the function of the brain was to serve as a secondary organ to warm and cool the heart and serve as a place where the spirit can circulate freely. Extraordinary. Here we have a statement that now, 24 plus centuries later, we can use to define the very essence also of jazz. An organ to warm and cool the heart, and a place where your soul can circulate freely. And that is the plan for this evening. Now, the master of ceremonies tonight is going to be Michael Shadlen, a professor of brain sciences at Columbia, that exemplifies the very essence of what we want to do, to bring brilliant minds that transit parallel worlds, science and art, to help us get to the core of what it means to be human and what it means to have a brain. So Michael is a scholar in the study of brain circuits and decision making, but today he's going to wear two different hats, where he's going to use his understanding of neuroscience to translate some of what we perceive as the soul of music into the language of the brain. Professor Shadlen, we're glad to have you.
Charles, thank you so much for the introduction, and thank you all for coming. Thank you for calling me human and saying I have a brain. Those are the two nicest things anyone has ever said. Okay, we good? So I'd like to thank you all for participating in what I hope will be a dialogue. It's a dialogue between artists and scholars and scientists. The artist-scholar in particular, Chris Washburne, on the faculty at Columbia. In fact, the entire band is a Columbia faculty band. It's going to be a dialogue between musicians among each other in the process of creating jazz, a creation in the moment, in the now, as they say, and between us, you and me and the band. And it'll be about idea, ideation, creation, and comprehension. Now, I'm going to tell you a little about myself. I'm a neurologist and a neuroscientist. I have an abiding interest in what it is about the brain that constructs, that creates, that gives rise to thought, but also why those processes fail in certain diseases and how we can do better to remedy the situation for our patients. Now, I think there's reason to believe that a small set of principles, or you can call them mechanisms, underlie a wide repertoire of mental operations that we loosely refer to as cognitive, something that lies between sensation and action. That's the stuff of thought. And I think that the breakdown of these fundamental processes also holds the key to understanding how the mechanisms that are responsible for disease at the molecular genetic level give rise to the manifestations of disease at the psychiatric, behavioral, psychological level. We want to know that because ultimately we'd like to treat disorders of thought, reasoning, memory, socialization. I'm lumping a lot of disorders of higher brain function. We'd like to treat those by intervening at a level of the nervous system that you could say is the answer to the question, what is it about a normal brain that makes it not confused? Now, my own research is about that problem, and I study the problem of how we make decisions. And so when this woman is facing this fork in the road, she's working it out, and she's working out her ideas about what might be at the end of each of those paths. The cost of spending time before, rather than waiting for more information to maybe make a better decision. Thinking about what the future might be using memory, what the psychologists call prospecting. Imagining that if she makes it to the end of a path, how costly might it be to come back and check out the other way? And if there's a reward or some kind of failure along the way, what does she want to learn about the path not taken? Now, all of those processes enter the mind, and we'd like to understand exactly how. And you can see why I think that decision-making, even simple decisions about left and right paths, turn out to give us insight into cognition in general. So I like to think about studying decision-making as a window on cognition, and I think that, as Jose Saramago said, that it's not so much that we make decisions, but decisions make us, meaning that it essentially defines who we are, even our character and our status as moral agents. So I think what we're studying is something in some sense larger than brain mechanisms. We're studying who we are. Okay, so that gets me a little bit closer to what we're about to embark on tonight, which is a dialogue about music and about jazz in particular. Now, you know, when an animal forages, meaning leaves the nest to go look for maybe something better someplace else, they go through a lot of the same kinds of steps that I just described. So I view that as a kind of an evolutionary, rudimentary process that allows us to see maybe deeper into the brain at the level of the biology what it takes to make a decision, and it makes decision-making a tractable problem. Now, we talk about foraging and exploring, and I don't mean exploring capriciously, but exploring in some directed way, asking sort of directed questions. Will that path work out or not? Not let's flip a coin and figure out which path to take. Then we begin to start thinking about a connection to creativity and improvisation. I like this quote from Wynton Marsalis. He said, in jazz, improvisation isn't a matter of just making any old thing up. You know, it's not like this woman's not flipping a coin about which way to go. Jazz, like any language, has its own grammar and vocabulary. There's no right or wrong, just some choices that are better than others. Now, what I'm going to do tonight with you and with Chris is we're going to discuss some neuroscience, and I'm going to show you neurons and things like that. But I think before I get too carried away, why don't I bring out the band, and why don't we play some music for you? All right. I'm a little on the shaky side. Chris, can you tell us a little bit about what the audience just heard and maybe introduce the band, please?
My pleasure. It's such a pleasure to be here tonight and to have this dialogue in front of all of you and share our worlds a little bit and see where they collide and collude with neuroscience. But before we do that, I just want to take a moment to introduce these fine musicians I have up on stage with me. As Mike said, they're all faculty members in the Louis Armstrong Jazz Performance Program at Columbia University. Someone who's the assistant director to the program and also the saxophone instructor, as well as one of the most original voices on the tenor saxophone in New York City, playing with everybody, and you can imagine, the fabulous Ulla Mathiesen. On bass, a gentleman who teaches bass at Columbia University. He's also really one of the busiest bass players in New York City that I know of. As a matter of fact, if you like what you hear now and you want to hear more, you can just go down the street to the Village Vanguard, and he's playing there tonight, starting at 8:30 with Tom Harrell, the fabulous Ugana Okegwe. And also an amazing, versatile musician that I've been playing with for many years. Someone who plays at the Jazz and Lincoln Center with Wynton Marsalis, has played with Arturo O'Farrell still, and with the Ray Barretto Band for many, many years, and also plays with Paquito de Rivera, and actually got his start playing with the Mamas and the Papas, believe it or not. The fabulous Vince Cherico. So I just want to take a moment before we get back to neuroscience to talk about jazz and what I mean by that. And what I like to do is turn to some of the founding fathers and mothers of this music and take note of how they defined it and what they said about it. And the first person I want to quote is somebody named Sidney Bechet, someone who's very important in New Orleans, a wonderful clarinetist. He's the reason why we have saxophone in jazz to begin with. He was the first one to bring that in. And when asked about jazz and what it was, he said, "It's the sound of freedom. It's the freedom that the emancipated slaves found, and they had to make sense of that newfound freedom. They had to create something beautiful out of ugliness. They had to transform, use the materials at hand, and improvise a new way of life." So for Bechet, it was a philosophy of life. It was a way of being, it was a way of navigating, it was a way of getting through. At the same time, this question about what is jazz continually gets asked even after 120 years of this music. And just recently, Wayne Shorter, one of the most famous musicians we have alive, wonderful tenor saxophone player, was asked, "What does jazz mean to you?" He says, "It means I dare you." Now, what's interesting about both of these definitions, neither one of these musicians are treating jazz as an object or as a noun. They're verbifying the word. In other words, it's an action. It's a way of being, it's a way of navigating through life. And at the center of that is improvisation. Now, improvisation is a very interesting thing because it doesn't just exist in jazz. As a matter of fact, it is the center of existence. Human beings improvise every single day, and if you didn't, you'd be dead. I'll prove it. Today, as you're walking to this wonderful event, you crossed 7th Avenue. Well, you started to, and you put your foot out, and you look, and you saw a bus coming. What did you do? You improvised and stepped back. Therefore, you're alive. We also improvise when we have conversations on the street, when we see somebody that we haven't seen for a while. We say hello, and they say hello back, and then we ask one of the most dangerous questions in the entire universe. How you doing? Because at that moment, we don't know what they're going to say, and we engage in improvisation. And indeed, when we engage with people, when we say, "How you doing?" and they say something that surprises us, we delve deeper and engage deeper. What jazz musicians did in the beginning and still do is they use these fundamental concepts of human survival and daily interaction and create an art form out of it. And so how we do that is we create spontaneously before your eyes. As a band, we have never ever played together before until right now. We've played individually with each other, but this is the first time that you're seeing. So not only did you see the rehearsal, you saw the dress rehearsal and also the performance right before your eyes unfolding. That's what jazz is.
So you guys might want to sit and relax because this is going to... So I'm going to share a little bit of neuroscience with you and try to make a connection between thought and art in general, and I think we'll try and bring it closer to jazz via Chris's expertise. So the way I think about it, I've already introduced the concept that our brains undergo a kind of directed exploration. Now, I would say that we do that in situations where it's not even obvious. Let me give you an example. I mean, what I'm going to bring you through are two concepts about prediction and resolution and time as an archetype aesthetic. I'll explain what I mean. So here's a picture, my son 30 years ago, and I'm going to fool your brains into seeing some motion. Now, this is just a film loop, but most of you are seeing him kind of expand, yeah? Here's another one, same starting picture, but it's a 4-frame loop, and you're probably seeing clockwise rotation. Why? Without getting into details, because we know something about how the brain processes motion, and we put a little energy out there that you will interpret as a little bit of motion. And then what the brain does is it doesn't just process it. It doesn't just do information processing with deep learning and Google's yada yada. What it does is it makes a hypothesis about where something might be a moment later, in this case, centrifugally expanding from the center. And it gets a confirmation of that, and you see that as expansion, despite the illogical fact that luckily Josh did not, in fact, explode. In this case, same thing, except that the motion you're being enticed to interrogate is a little bit of a displacement in a clockwise direction. You get a little bit of a feedback, a little confirmation, a resolution of that prediction that your brain made, and you continue to sort of see this as rotation. Now, you might get sick when I stop this, so be careful, because you get a pretty bad after effect, most people do. Okay, so that's what I wanted to show you. I'll give you, I think in the interest of time, I might show this illusion to you at the end if we have time, that we can get back to the music a little quicker. Now, sorry, we'll come back to that. Time, I would argue, time is really the key to thought. Now, in my lab, when we study decision making, and we do this by recording from neurons in brains of animals, what we noticed is that in the big parts of the brain that connect the sensory information to the what are we going to do about it, in other words, as I said before, the stuff of thought that intervenes between information processing and actually using that information, believing in it, deciding, that these neurons have a sense of time. In fact, we just have a paper that came out today about this topic. And it's kind of interesting that they have a sense of time. They don't have time sense like a clock does. They have a time sense in an anticipation way, okay? So again, the sense that something is predicted to occur in the near future, say Afghana is playing a note, and I have a sense, because his time sense is so amazing, that the next one's going to come at some point, but he swings it a little bit, and it's a little bit delayed or a little bit anticipatory, and makes us shiver a little bit. And it's all subtle, right? But what our brains are sensing that, predicting when things are going to occur next. Well, I want to show you a very simple demonstration. It's the only science thing I'm going to do, really, in terms of showing you brain things. But you're going to get to hear, we did title this The Sounds of Science, and one of those sounds is that when we record electrical activity from the brain, we can play it to you through a loudspeaker like it's music. It's not very pretty music, it just sounds like a bunch of clicks. I'm going to play you that because I think it's a fun thing to get to listen to cells in the brain do the stuff of thought. So this is a very simple experiment. It's probably the simplest one we've ever done in my lab. And what we do is we ask the animal to time an interval. He sees a spot, now he sees a second spot, and the deal is when this spot dims, the first one, make an eye movement to that second spot. Okay, that's it. Now the thing is, the amount of time he's waiting for is random. Sometimes it's a second. That's the most common time. That's what this graph is showing you. It's never more than 2 seconds. It's never less than a half a second. And this is sort of the kind of probabilities that are sampled. Animal gets to know that. It gets to know the structure of the time of the environment. Okay, just as we do. We play music. In another context, here's the trick. We show him times that are short, like around a half a second. We never show him times around a second, and we also show times around 2 seconds. So the technical term for this is a bimodal distribution. It has 2 modes, one around a half second, one around 2. Okay, same thing happens. Now what I'm going to do is I'm going to show you what a neuron in the brain does when the animal knows that it's very likely things are going to occur in that first mode, something around a second. And what I'm going to do is I'm going to show you a case where he had to wait around for a second and a half. And what I hope you hear, I'm sort of leading the witness here, but what I hope you hear is that the activity of this neuron, these clicks you're going to hear on the loudspeaker, if everything works right, are going to increase in frequency and intensity as if the brain is anticipating the arrival of this go signal. Let's listen. You hear the rise and the increase in the frequency, a bit like a crescendo, but it's more of a crescendo that Vince would do, you know, rattling away. Now let's consider another one. Now we go to that other context, and in this context, the animal knows that time doesn't ever happen at a second. It's always either short or it's long, and with a little randomness around either of those times. And once again, we're going to ask, okay, what happens if he's sitting around waiting for one of those long times? What's the brain doing as the waiting is going on? And again, just to sort of feed you the intuition, is that maybe anticipating early, but if that doesn't come, then stop anticipating and then anticipate again. So kind of a triphasic, rise, fall, rise again, okay? So see if you can hear that in this recording of a neuron in the brain. You got it? It came up, it went down, and it came up again. Everyone get that? Okay. So that's what you're hearing is a cell in the brain that's keeping track of time. Why? Because keeping track of time is what makes us be able to think. It makes us infer cause and effect. As a child, something hits the floor, and then the noise comes, okay? And so forth. Or you did something silly, and then the pain comes, okay? So we have to learn about the structure of time. And I would say that in general, time is sort of the core of higher brain function, and I'm going to say in a moment, the aesthetic. So I like to think about the secret of thought, of cognition, or really many, many, many mental processes, is a kind of freedom from immediacy. The need to use information not on the time frame of the immediate changes in the world around us, and not in the immediate now time frame imposed by having to control our bodies. That's it's an engineering problem, a really interesting one. But thought resides, again, between those two extremes, and it must have freedom from immediacy. And in many disorders, I'm thinking now of many patients that I treated in my neurology days that involve global confusion. What happens is there's a failure of this mechanism to be able to keep information through on the order of seconds, like this example, or maybe longer, tens of seconds. And think about it. If information was just to come into the brain and have to die away instantly if it didn't cause an action, there would be no way to make sense in any flexible way beyond a reflexive sense. There would be no way to make any sense of the past connecting to the present, connecting to the future. Okay, we'd be hopelessly confused. Okay, and that's what happens to people, unfortunately. Okay, now I want to bring it back to the aesthetic, and then we'll play some music. So, what I'm trying to tell you, or the hypothesis or the thesis, is that thought is a kind of directed exploration. It involves a prediction and some kind of resolution of that prediction. And time, I just gave you as an example, is sort of an archetype. It's paradigmatic for this basic property, which is true of lots of things. It's true when we looked at that movie of the rotating baby. Okay? There was some sense that our brains were led to predict something, and it was the fulfillment of that prediction that led us to, in this case, the illusory sense that that baby was rotating. Now, I would say there's one extra thing I'll throw out, and then I need to hear Chris on this, and that is the step that's missing, into my mind, that gets us to the aesthetic, to art, is that the artist is imbuing a sense of anticipation in the beholder, in our case, the listener, in you. And by maybe exploring outside the key, playing with the time, teasing a bit, and creating a little of tension before maybe resolving, coming into the beat, or returning to the key center. That's the essence of what, in music, we would say makes something interesting, at least, not necessarily pretty. Maybe it's even ugly, but interesting and artful. And we could talk about the same thing. I had the pictures of the dancers up there, where gravity seems to imply a certain resolution, but there's a certain defiance of it, and then it resolves. In painting, we could make the same kind of statements about curvature and forms that tie down our sense of expectation, but then there's some tension and release. I love this quote from Dave Liebman, who is a jazz, he's an NEA jazz master, right? And so art is constant tension and release. That's where the artists live, between two, or at times, or between the two, right, sorry, or at times submerged in either. I think that's a really interesting way to think about jazz. So look, what I just said, I think, is about a general statement about the aesthetic and trying to relate it to the kind of brain science that, again, interests me in part because ultimately I see it as the key to understanding higher brain function and curing disease. That's, my motivation. But there was sort of a generic sense of the aesthetic there, and I'd like to hear, so Chris, like what is special about the jazz part of that?
Well, personally, I'm interested in what you have to say, but I'm more interested in world peace and happiness. And I think that
I'm against it, Chris.
I think that also lies in time, but also the plane of time, and also the notion that it's not only tension and resolution, but it's also love and fear. And those play very important roles in jazz musicians' lives and in terms of our aesthetic. But in order for us to be able to do this, what we have to do is we have to fix ourselves and emplace ourselves in the present and nowhere else. Our relation to time is just truly present. But indeed, we manipulate it, and we manipulate the perception for various affect and to try to make the music compelling. But the idea is that to be fully present, to be nowhere else, where there's no other thoughts, is where blissful moments lie. It's what psychologists call the state of flow, when you're so into whatever activity you are into that you lose track of time, and that you lose track of almost yourself as you delve deeply into it. It's the moments of our most happiest moments in life, usually. It happens during sex. It happens during an incredible conversation with somebody. It happens when we create and we improvise and build something and make things. And so in order for us to do that collectively, though, and not individually, some things have to be in place. That is, fully present with each other. In other words, when people oftentimes ask us, what do you think about when you play music? What do you think about when you're taking a solo and you're improvising? Well, the real answer is nothing. Wayne Shorter said, I imagine the world what it could be and what it should be. In other words, nothing. He's just interacting with the sounds around him and his emotion, and he's trying to communicate with the audience, and that's what we're trying to do as well, and with each other. And in order to be able to do that, we have to develop some very deep listening skills. Listening skills that a lot of people don't practice in their daily lives. I remember the first time that I was in college, my first class, my assignment, and my teacher was Richard Davis, a wonderful jazz bassist. The first assignment was to go out and listen to a concert that night. I was like, wow, damn, I like college. I don't have to read a book. I don't have to write anything. I just have to go to hear music. And he was like, no, I want you to go and really listen. And I'm like, well, of course I'm going to listen. What am I going to do? Sit there and fall asleep? He goes, no, I want you to listen so hard you sweat. And I thought about, what could that possibly mean? Can you imagine what it would be like to be so connected that you're sweating and you're listening that deeply, which means you're not only listening to the sounds, but you're listening to the emotions, the spirit, and all of the intentions around you simultaneously. There's no more space for anything else with that kind of connectedness. I'll show you what it's like. Well, would you like to know what it's like to be a jazz musician? Well, whether you do or not, I'd like to try an exercise with you. if you have something on your lap, if you could just place it on the floor or on the side. And I'm just going to have you do a short little exercise. I'm going to give you a series of instructions, but I don't want you to do the instructions until I tell you. The first thing is that I'm going to raise the mic. There we go. The first thing is that I'm going to clap a rhythm. What I want you to do is I want you to listen to that rhythm. When you feel comfortable, I want you to join me, okay? Okay, anytime you like. Good, don't rush, right with me. The secret of grooving collectively is to relax and to smile. Nice. Now, I'm going to stop clapping, but you can't because you're the drummer in the band right now. So you must keep going. No matter what, you do not stop clapping. I want you to listen to those around you and see if you can hear them clapping with you. This whole room should sound like just one person clapping. That's right. You make that adjustment, you negotiate, you're manipulating time, you're anticipating the time. Beautiful. Don't stop clapping, whatever you do. If Vince stopped playing in the middle, the music would stop. Okay, now, I'm going to give you another set of instructions. Without stopping clapping and without losing the groove, I want you to turn to the person that's closest to you, not yet, and you're going to ask them what their favorite color is. Now, they're going to respond what it is and why, and they have to use a complete sentence. And then when they're done, you're going to switch, and they're going to ask you what your favorite color is. The whole time, not losing this groove. Ready? Go. Everybody get back to the groove. And stop. Now, I just want to take a moment for you to reflect on how you feel right now. Some of you are relieved that you're stopping clapping. You have some sore hands. I realize that. But I also am seeing a lot of smiles, and I'm seeing a lot of bright eyes, even brighter than they were before we started. Why? Because I forced you to be nowhere but here. Because your brain doesn't have the ability to do more than what I requested. You had to keep time. You had to listen around you. You had to respond to my instructions. And then I really forced you to improvise because I highly doubt you had an answer prepared about what your favorite color was. And you didn't expect that that's what I was going to ask you to do. So you actually had to form a duet and interact with one another. That's what jazz musicians do when they play. They have to get to that place. The only difference is our conversation is with 5 separate people simultaneously, as opposed to just one sitting next to you.
So maybe we should play another tune. And do you guys want to clap while we play? No, please don't do that. But maybe we can do something else, though, and see the band, these guys, I mean, you know, these people are just incredible, and they communicate. I don't know if you heard all the communication going on in Turnaround, the tune we played first, but we'll play a slower tune now, right? And see if you can catch the back and forth and the exchange of ideas that goes on during this tune. It's a Thelonious Monk tune called Round About Midnight. Well, do any of you have any questions you'd like to ask about to the band, about the music, about what happens, about the neuroscience, anything you like, anything that's on your mind? When are you playing next? Thank you. That was very nice.
Actually, a couple of questions.
Yeah, great.
So yeah, I'm just curious. Oh, yeah, I'm just curious. So, you discussed this idea of one of the bases of cognition being, I think the term you used was freedom from immediacy, right? Whereas I felt like what Chris was saying about about music and about what he feels when he plays music is almost the exact opposite of that. Is a freedom to engage in sort of the immediacy of the experience. So I was wondering if you could talk a little bit about that and.
Well, I think that the two are compatible. I mean, what allows us to use the information at various levels, not just the next beat, the measures, the phrases, the section, the cadence, is using the past in order to inform where we hope the future is going to go, including when we're creating the future with an improvisation. Now, of course, I think Chris is just spot on with the idea that we have to do that in time in music, and we, in a sense, experience it so immediately in the now that it just, it brings us right there. There's something very special. I think Chris rose to the challenge. What's special about jazz, and what's special about jazz that makes it different from literature or, having a conversation with your friend? And all of these things happen when we do that. Doing mathematics, we have a sense of completion. We complete it. We work through the proof later. In our mind, it had a sense of completion before we started. Yeah? But there's something very special about jazz where things are really right there then. I don't know, I don't get to do this very much. And I mean, to be able to play with these guys is just like such an incredible treat. You have no idea. I watch these guys in clubs all the time. But that's what they're doing with the sounds and the ideas. It's just, it just takes you to a different place. And I mean, so thank you guys, because you've just taken me to a different place. So
I also think that to respond to your question is that I love to disagree with Mike, but we have to think about two different senses of immediacy. Because one thing that I've learned with my conversations with Mike is that time in the neuroscience sense is a little bit different than how we actually experience. And so in some ways we have to be fully present, but what's happening in our brains actually when we're improvising, there is time there is delay, and it's a different sense of time that seems to be happening with those electrical responses.
Yes, in the back.
What happens to the brain when you hit a sour note?
Has it happened? Really? Has anyone noticed those sour notes? There have been several. Sorry. Well, it's a great question. The brain is always learning, right, from its experiences, including the experiences we create. And I mentioned this, the woman's going down that path, and presumably what happens during that path might be informative to which path to go down the next time she's in that same kind of a situation. And there is this sense of expectation of a completion. I think it's a bit like the expecting a reward. We find some satisfaction when the tension is resolved, when the key comes back, when the beat does land after maybe playing a little bit with the time. And when we oops, when we don't hit what we meant, when someone fooled us, we might hear that as a little humor. We might hear that as yet another more tension, that thing that Dave Liebman said, that sort of living both in the tension and the release simultaneously. But the brain does have a very strong activity that we don't fully understand when an oops occurs. And in fact, the difference between people who wake up from coma and the people who remain in coma can be sensed with EEG electrodes now, based on the presence or absence of a kind of a high-level oops signal, because they're in that moment. They're creating predictions, the brain is, about what's going to happen next.
I can answer that question from a jazz musician's brain, is that you have to understand that our mandate in our profession is to, every time we go to work, create something new. And we have to do that in front of an audience. So that means that peril is just around every single musical phrase and every single note that we play. But we have a very different relationship to oops and failure than I think other segments of society. And that is, we take that as opportunity. And the mistakes that happen in jazz is when you don't capitalize on those mistakes. Because it's when you play the wrong note that all of a sudden the musicians now need to contend with that new sound. And what do we do with it? That's the moment when we actually create something new.
So I'm going to stop the questions because we have to close the set very soon. And I think it might be nice to play one more tune. Is that okay? And the thing is, some of us will hang around and answer your questions anyway. And of course, this is a dialogue, really, as I said, and the dialogue continues. What we're doing here is, it's not just a dialogue among musicians, it's not just a dialogue among Columbia people, and it's a dialogue with the community as well. And we're going to, Chris and I are part of trying to establish a scholar/artist in residence program at the new Jerome Greene Science Center and the Zuckerman Mind Brain Behavior Institute, where we will have this kind of interaction, and that interaction will include our neighbors in the community, and which I think it's just the right home for jazz in New York. And so we'd love to hear your input on those kinds of things, and we'll discuss with you how the brain works. Okay?
We'd like to play a song that was written just a few blocks from the new building. And it was really about communication, a communication across scholars, across cultures, amongst musicians and deep thinkers about this music. And I'm talking about a song that was played in Duke Ellington's band, one of his biggest hits, but it was not written by him. And this is something called Caravan, written by Juan Tizol, the first Puerto Rican to be hired into his band. And this is about their many journeys, meeting lots of different types of cultures and bringing those types of musics in to have a broader global conversation. We hope you enjoy. Vince Cherico on the drums. Ugana Kegwo on the bass. Ula Mathieson on the saxophone. And Mike Shadlen on the guitar, yeah! My name's Chris Washburne, thank you so much.
These guys were absolutely amazing. So, we get a couple of scientists that have never worked together, and we try to get them to do an experiment together. The likelihood that that will work is 0. This is just theory. Now, before I close the evening, I want to thank our second grade philanthropic visionary, and that's Mort Zuckerman. Yeah. We like to acknowledge Mort truly for giving us the opportunity to engage in the exploration of what we view as the boldest and greatest scientific journey. A journey into the center of our memories, emotions, actions, and behaviors. So on behalf of everyone at the Mortimer Zuckerman Mind Brain Behavior Institute, at the Jerome L. Greene Sciences Center, we like to once again thank Mort and Chris, and thank you all for being here. And I hope we'll get to see you soon, where musicians will talk about neuroscience. And maybe then you'll get a window into the break. Thank you.